So now we want to spotlight one of our management consultants, Eddie Solaris, and how we use what's called the Monte Carlo technique in one of our recent projects. This next presentation might get a little bit technical, but please stick with us. It's actually a very exciting project. It's one of the new things which we've developed a capability to do for our clients. It's actually how to use the Monte Carlo technique around cost estimation. So over to you, Eddie.
Okay, hello everyone. Let's see if I can share my screen successfully. Let's see, try and, is that good, everyone?
You're good, you're good.
Okay. All right, so the project we've been working on, sorry, my name's Eddie Solaris. I'm with the management consulting team. So the project we've been working on is the Canadian Art Lifecycle cost model, and I'll go into the details in a little bit. Move this slide a little bit. Okay, so the client's pursuing the Canadian Remotely Piloted Aircraft System program. Part of the program in the draft RFP is that they have a little cutaway section where they provide a detailed description of the proposal evaluation methodology. So it's summarized using a life cycle cost approach that balances both program risk and cost uncertainty. The life cycle cost encompasses both the acquisition and the operation and sustainment part of the program over a 25-year lifespan cycle, which is kind of an interesting approach because we don't see many contracts that actually take into account the entire life cycle costs, or especially the operation sustainment part of it. So really at the heart of the model is the Monte Carlo implementation. And I'll go into the detail what I mean by Monte Carlo for the method in a little bit. But the client asked us to kind of create this this model that incorporates the Monte Carlo approach using all the data provided by the client. And then we also perform a sensitivity analysis, which if you're familiar with financial modeling, it's kind of, you change the inputs a little bit to see what the output is and see which of the parameters have the most effect on the output. And the programming language that we use is Python. And that's mainly because Python is a great starter language in the sense that, you don't really have to get too into the weeds with learning the code because there's a lot of library packages out there that both scientists and data scientists use in everyday life. Okay, so I'm gonna switch over the slides. So this is kind of the grouping that Canada laid out. So on the left-hand side, we have the acquisition. On the right-hand side, we have the operation and sustainment. So this is kind of the way that Canada grouped it. And so this is familiar to a cost breakdown structure. And every little piece of this that you're seeing here has to be priced out. And an associated risk and associated costs have to be mapped out to each element here. So the client really delivers in-depth view of the risks and the costs for each little segment of the entire plan. And so here's a process overview. So I'm gonna go through this a little bit slowly than the other slides. So what goes, the process really starts off is that we have to create a template for inputs. So what we do is create 4 templates that can be ingested. And I'll go into what the templates are. So these are mainly Excel files that get ingested into the algorithm so that you could change the inputs, which are the costs, the risks, the maturity indices, and other parameters. And these all get fed into the ingestion module. So with the ingestion module, step 2, what it does is that it parses out all these Excel files. It reads in all the data. It formats it correctly. It cycles through them and then gets them ready for the Monte Carlo implementation, which leads into the third part. And this is really the kind of the heart of the program, the Monte Carlo. What it does is it takes everything the client feeds the model, and it really just picks out one specific point, and then it runs the model through with those points. And by one specific point, I mean many specific points. So the model actually has a bunch of uncertainty distributions, a bunch of risk distributions, and it picks random points in those distributions and then runs with the model. And then this is kind of done a lot of times. We're talking about, in order to do it quickly, we're talking about like 15,000 times, but you can technically run this, have it running for like an hour and do it like 100,000, 200,000 times. And obviously, the more times you do it, the better sample size you get and the better results you get. So, what this does is it creates a distribution of the acquisition and the operation and maintenance costs. And then, according to the RFP, it chooses the 80th percentile. That feeds it into the cost part 4, which is the cost points and scoring model. And the 80th percentile is taken, converted, adjusted, and then a final single number comes out. So what really is the great thing about this is that it takes everything from the acquisition to the life cycle cost to the risk to the uncertainties and just spits out one single number without any, there's no bias in this model. And so you can run this for yourself. And then part 5 is kind of like a sensitivity analysis where you kind of tweak the parameters and then see what the final result is. And the final results, depending on what you put in, it will be able to tell you which parameters are more important. So let's move on to the next slide where kind of talk about some of the templates. So there's kind of 3 templates the client needs to put in and one, random parameter file. The lifecycle cost template, that's mainly a cost with its associated uncertainties. So say a certain part costs 50 million, but there's a chance that it might cost anywhere from 40 to 55 million. You put that uncertainty distribution around it here. The cost risk register template, that's the template that associates each of these costs with a certain risk. So there's a 10% chance that your product might be delayed, which will cost you, 20% more. So the model actually runs through, does this happen in the 10% chance? If it does, adds the extra costs or the extra whatever it is. And so it really adjusts for risks. The cost element maturity index template, this is mainly for Canada. Canada is supposed to do these. These are maturity adjustments with, they go from 0 to 1, with 1 being a perfectly mature solution, a 0 being immature, completely immature solution. And these are really up to the discrepancy of Canada, but the client's allowed to, kind of tweak with these, kind of put the worst case scenario, say if we got a 0.85, that's kind of what they'd go here to see like what the worst case scenario that they'd get. And then the model execution parameter file, that's just an outside file. So you don't want to be digging into the code to like change variables. So what's easier to do is just, kind of put it in an Excel file. How many runs do you want to do? You just put it in an Excel file and just change the Excel file and run it again. So pretty simple. Just as simple as running the program. So all you have to do, so this is when we deliver to the client. They just have to install Python, set up the directory correctly, and move to the directory and run the program. It's pretty simple if you're familiar with programming. If not, we did offer the client additional help and support. And what we use is Anaconda, or what I use is Anaconda, is because it has a lot of Python libraries kind of built into it. A lot of scientific, a lot of mathematical, a lot of data science packages are already come in like this one neat little package. So there's no need to like dig around for other libraries that you might need because it's most likely in this package. Assumptions. So I won't get into these. These are mainly assumptions we deliver to the clients. Oh, and I do have to mention that this slide set is sanitized. So nothing you see here is really makes sense, but for the client, it does make sense when we actually run it correctly. But this is sanitized for the purpose of presentation. And these assumptions really are kind of, we recommend the client to do this. We don't recommend the client to do this. The client should do this. We just kind of guide the client, into how to really use the model effectively. And here are 4 examples of the probability distributions. The triangle, PERT, Gaussian, uniform. You're probably familiar with some of these. You kind of put in the most likely, the min, max values. And these are both for the risks and both for the costs. So each cost and each risk associated with the cost has a distribution around it. The Monte Carlo chooses a random point in this distribution and runs with it. That's one iteration. Then we run it again and it chooses another random point. It's kind of like rolling dice multiple times and then collecting all the numbers. And then you have a distribution of all the total sum of the dice. And here's kind of a sample output program. So it takes all those runs and accumulates them into a distribution. What the client wants is taking the 80th percentile from this distribution. And we have one for the acquisition, for the operation and sustainment, and the total cost, which is just the sum of the previous 2. So the 80th percentile gets fed into the program. The maturity adjusts some of the values towards a higher cost. A less mature solution ends up with a higher cost, which is worse for the client, obviously, because you want to have the lowest bid in there. This is just kind of a normalization step. And finally, this is kind of what it looks like, the output. There's a final score at the very bottom. The command prompt will tell you if there's any errors, and it'll just kind of tell you everything that's going on, and it'll finally spit out a score. And then you can rerun the model again, change the parameters, see what the score is after, if you want to try it for a higher score. And this is essentially what Canada is doing. And we're trying to redo what they're doing so that the client is able to have, a little tool set on their side to, see how the final score changes based on their input changes. So I'll just quickly glide through this. This is a sensitivity analysis. As I've said already, we just changed the parameters for the inputs. And since there was 4 templates, one of them doesn't really count. The 3, the cost maturity, the life cycle cost, and the risk templates, these all the parameters on this file get adjusted by a certain percentage. And then we see what the change in the final score is. And this gives us a number. So these are kind of sample outputs. On the left-hand side, it doesn't matter which one you read. You see the indices ID or risk ID. It kind of tells you the output based on the sample. And the higher the number, the more it affects the final outcome. So we'll skip over this. So essentially, what we're delivering to the clients is a draft version. There's still a lot of variables that are missing. There's a few functions that need to be defined. There's worst case values that need to be defined, and everything here is kind of sanitized, but there still is a lot of work to be done. What we're currently working on is an updated version of the model. It's a bit more streamlined, but the bulk of these variables are still missing. And there will be more nuance to the answer at the very end. But when the clients have this tool, they'll be able to kind of use it to not only kind of score themselves, similar to how Canada will score them, but also really see which variables, if you gotta increase your score, you can really hone in on which variables actually matter. So which costs matter, which risks associated with which costs matter. It'll really allow you to do all that.
My meeting.
And that's it for the presentation.
Thank you, Eddie. That was fascinating. As I had mentioned at the beginning, it was going to be a technical talk, and it surely was a technical talk. It's an incredibly powerful technique. It's been in use for decades, even by Department of Defense programs, as well as commercial programs and in business ventures, et cetera, as well as in scientific fields. But this was a really interesting application of Monte Carlo to help really get a handle around life cycle costs and its drivers and sensitivities. So thank you, Eddie.
Actually, AJ, we use this in PP&C for schedule risk analysis as well. We use Monte Carlo.